So up to this point, we've only been able to integrate the 6 basic trig integrals. So I want to review those with you first. What is the integral of sine? What is it?
Cosine.
That would be negative cosine. And remember that negative, you have to kind of double check and balance there. What's the integral of cosine?
Sine.
Mm-hmm. So we have sine x plus c. What is the integral of secant squared? Plane tangent, right?
Mm-hmm.
Notice that in all of these, what's the angle? Just x. Notice that the angle does not have a derivative other than 1. What is the integral of cosecant squared?
Negative.
Is it cotangent or negative cotangent?
Negative.
Negative cotangent of x plus c. And we need that negative there to kind of balance it back. What is the integral of secant x tangent x?
Secant.
What is the integral of cosecant x cotangent x? Negative cosecant?
Yes.
Okay. So notice that up to this point, we have only been able to integrate the 6 trig derivatives and bring them back to the original trig functions. And we're able to work with coefficients and positives and negatives as we need to. But we haven't been able to do any other combinations of trigs, and we haven't been able to do trig functions to a power other than these two. And it's just because those two happen to be 2 of the 6 basic trig functions. And that all of the angles have been 1, and therefore the derivative of all the angles has been 1. So if I take the derivative of, not the integral, but the derivative of sine of 3x, what do I have to do at the end?
Multiply by the derivative of the angle.
First I have to keep the angle, then I have to multiply by the derivative of the angle. So that the derivative of sine of 3x is 3 cosine of 3x. So we're also going to have to reverse that chain rule when we do trig integrals that have an angle other than 1. So we're going to look at a couple of those first. If I want to integrate the cosine of 1/3 x with respect to x, if that x over 3 weren't there, if it were just cosine of x, the answer would just be sine of x plus c. Make sense?
Yeah.
But because we have an angle other than just 1x or 1 theta, we have to make a sacrifice for the derivative of the angle. So that's the first thing you learn about trig functions, is if the angle isn't 1, you have to sacrifice the derivative of the angle. So before I can integrate this back to sine, I need to give away a what? What's the derivative of x over 3? It may help if you think of it as 1/3 x instead of x over 3. You need to give away a 1/3 dx. Okay, so that's going to be the reversal of the chain rule. Okay, so that's what you need to give away. That has to disappear first. So we're going to insert a 1/3. And it doesn't matter where I put him. Like, I'm just going to put him over here because I have a little more room over there. But if I insert a 1/3, I have to put what out front?
A 3.
The reciprocal to balance it. So this is the derivative of the angle. And at the end of differentiation, you multiply by the derivative of the angle. But at the beginning of integration, you have to sacrifice the derivative of the angle, which is sort of like dividing by it. So this guy is gone. And what that does is it allows you to reverse this cosine back to sine. So the only difference here is that before we can integrate one of those 6 original trig functions, we have to sacrifice the derivative of the angle. So you have to give that away to reverse that part of the chain rule, or the TA rule. Any questions about this one? And you should be able to check it by taking the derivative back. If we want to check it, we keep the 3, the derivative of sine is cosine, keep the angle, and then multiply by the derivative of the angle. And the 3 and the 1/3 would cancel, and that would bring you back to the original problem. For this next example, we have the integral of secant of 3x times tangent of 3x with respect to x. If that were just a secant x tangent x, the answer would just be secant x plus c, because that would be one of our original 6. But because we have an argument or an angle that's not just 1x, we have to give away the derivative of the angle as part of the reversal of the chain rule. So, since we don't have a 3 available, we're going to make one up. And we're going to just multiply a 3 in where we need him. And we're going to use him as part of that sacrifice there. But if I put a 3 in, I have to balance it with a 1/3. And what this does, this chain rule reversal right here, sacrifice to the integral gods, that gives you permission to integrate just like you would if that 3x weren't there, if it were just an x. So that will bring it back to 1/3 plain secant of 3x plus c. And you should be comfortable enough at this point with trig derivatives to check that.